So now we know how to write a chemical equation, we know how to balance it. Now we're going to look at the different types of reactions that chemicals can have. And as it turns out, there are 5 different kinds of reactions that we're going to learn about in this class. And we're going to learn about the first 2 of them in this lecture. These are synthesis reactions and decomposition reactions. We're learning these 2 together because they're both pretty simple, so it's a nice, easy way to start. Okay, and thankfully, these names kind of give us a hint as far as what is going on. If you know anything about the word decomposition, that usually means to kind of like break down. And to synthesis or to synthesize means to like make something. And so that's essentially what these reactions are doing. Okay, so with the synthesis reaction, we are taking 2 elements and we are combining them to make a product. Okay, so just in like general symbols here, these aren't meant to be elements necessarily, but this is what's happening. We have element A plus element B makes this compound AB. Okay, and if we have a metal and a non-metal, that's going to make an ionic compound. So here's an example: lead plus oxygen makes lead oxide. Iron plus chlorine makes iron 3 chloride. Okay, one thing to notice is that these little numbers right here, these are diatomic elements, right? So that's why there's a little 2 there. And then when we're going to write the formula here, we're balancing charges. Okay, so again, we would be looking at our periodic table, figuring out if it's one of those transition elements, if it can have more than one charge or not. So lead, if we look at lead, it can be +4 or +2. Well, how do I know which kind it is? The +2 is in bold, so I'm going to assume this is the +2 kind, which means this lead has a charge of +2. This oxygen has a charge of -2, which is why they go together 1 to 1 to be PbO. Whereas if we look at iron's box on the periodic table, it can be +2, +3, or +6, but the +3 is in bold, so I'm going to assume it's the iron 3 kind. And so that means this iron's going to be +3, chlorine's always -1, which is why I need 3 of them to balance this out. So notice I don't just take this 2 and plop it over here because that wouldn't balance the charges. This 2 just doesn't plop over here. I have to write my formulas by balancing charges. Okay, so don't forget that. So there we go. Those would be the 2 synthesis reactions for those elements. Of course, these are not balanced. And so, let's just get some extra practice. Let's balance them. If we look here, we got 1 lead, 2 oxygens. Uh-oh, only 1 oxygen. Okay, so I cannot change any little numbers, no subscripts. I can only add in coefficients, big numbers in front. So that means in order to fix those oxygens, I can put a big coefficient of 2 right here. And so now that gives me 2 oxygens, but it also gives me 2 leads. So that's going to mix things up because I only had 1 lead here. So now I have to go back and put a big 2 right here. And so now let's double check. 2 leads, 2 leads. Oxygen, there's 2 of them. 2 oxygens balanced. Let's look over here then. Similar balancing. If we look very clearly, the chlorines with a 2 and a 3 are not equal. As we talked about before, the only way that 2 and 3 can be the same is to make them 6. So I'd have to add a big 3 in front of my chlorine right here and a big 2 in front of my iron chloride. So that now fixes our chlorines, but now we have 2 irons because this coefficient here applies to everything behind it. So this 2 now, not only does it makes it 2 irons, but 2 times 3 is 6 chlorines, right? So now we need to have 2 irons, so I got to go back and put a 2 in front of it. So now I have 2 irons, 2 irons. 3 times 2, 6 chlorines. 2 times 3, 6 chlorines. Everything is balanced. But the main idea is element plus element makes compound. Element plus element makes compound. In this case, they're ionic compounds because metal, nonmetal, metal, nonmetal. But as we know, ionic compounds aren't the only kind of compounds. Sometimes we can have 2 nonmetals coming together, and that's a molecular compound. So here we've got carbon plus oxygen makes CO2 or CO or CO3. What? Wait, So the thing is with moleculars, we're not going to do a lot with them, but at least at this stage in the game, you could write any answer over here that is a carbon and oxygen combination that you've heard of before. Most of you would probably put CO2, okay? N2 plus H2, that's NH3 or NH4, those are off your ionic sheets. Or if you had like an H2 plus an O2, a lot of you would probably write H2O, right? We're not going to do many of these because you, at this point in time, don't exactly know what they make, but you know they've got to make some kind of combination of the 2 elements that you were given as reactants, okay? So now moving on to decomposition, right? If something decomposes, it's breaking down. And so this is exactly the opposite of photosynthesis. Now we are taking a compound and we are breaking it down into its two individual elements. So here is an example. Water, if you break it down, becomes hydrogen and oxygen. Potassium chloride, if it breaks it down, becomes potassium and chlorine. Okay. And again, the subscripts of 2 are because these are diatomics, right? Okay. And so we're just going to now balance these just because it's some good practice. So here, if we look, H2, H2, O, O2, uh-oh. O's aren't balanced. We got to fix it over here. We would need to put a big 2 in front. So now I have 2 oxygens, 2 oxygens. But now we have 2 times 2, 4 hydrogens, and only 2 hydrogens. So we have to put a big coefficient of 2 here to make it 2 times 2 hydrogens. Okay, so that one's now balanced. And then for here, notice our chlorines are funky. So in order to fix it, we would have to put a 2 over here. But now that gives us 2 of everything behind it. So not only 2 chlorines, but 2 potassium. So I'd have to put a 2 right here to balance it. Okay, so decompositions are pretty simple. You just take the one thing, you split it into its 2, and either it's single, okay, or if it's a single thing in a diatomic, they just have to add the little 2 behind it. Right here we have 2 diatomics, here we have a metal and one of our diatomics. Okay, so synthesis is taking 2 elements and smushing them together into a compound, and decomposition is taking a compound and splitting it into 2 elements. That's it. And we will do more practice in class with this soon.